Hello, welcome to Maths with EJD. In this video, I'll start taking the tests under hypothesis testing one after the other, starting with the parametric test and then the non-parametric test. So in this video, I'm just going to take Z test. In the next one, I'll take one sample T test and so on and so forth. So Z test is the focus here. So the Z test is a statistical test. The statistical test used when you want to determine whether there is a significant difference. There is a significant difference between the sample mean, and a known population mean. Okay. It is primarily used in cases where one, the sample size is large. The sample size is large. That is, n is greater than or equal to 30, or so either the sample size is large or the population variance is known. So even if the sample size is not large, at least if the population variance is known. So either of these first two conditions, in addition to the third one, and so either the first or the second, and that the data follows a normal distribution, Okay. So the Z test, compares the sample mean, which you can call X bar, to the population mean, mu, using the Z score, which tells us how many standard deviations the sample mean is from the population mean. Okay. So what is the formula for the Z score? Because I've shown this a couple of times, but it's never too much. Formula for the Z score. So the Z score is calculated using the formula Z equals X bar. I like to use small x bar minus mu divided by sigma over square root of n, where X bar is the sample mean. Okay. Mu is the population mean. And sigma Sigma is the population standard deviation. Because once you know the variance, you can know the standard deviation because standard deviation is the square root of variance. Sigma is the population standard deviation, which is known in this case. Okay. In some other cases, it won't be known, so you can't use that test in that case. Then N is the sample size. N is the sample size. Okay. Now, let's talk about the hypothesis. What kind of hypothesis do you have for a Z test? So you say hypothesis in a Z test, right? So first you have the null hypothesis, the null hypothesis, what you can call H naught. So the null hypothesis is simply something like this. Just make a statement. You say the sample mean is equal to the population mean, is equal to the population mean. So your hypothesis is simply that x bar is equal to mu. That's the hypothesis. Or another way in which you can say it is that there's no difference between the sample mean and the population mean. That's another way to say it. Okay. Let me write that. Or there is no difference. There is no significant difference between the sample mean and the population mean. That's another way to say the same thing. But the short way to say it is you can just say H naught equals X. H naught is such that X bar is equal to mu. That's also the same. You can also say it that way. I mean, you can just say H naught is such that X bar is equal to mu. That's also good. So to say that the sample mean is just the same as the population mean. So that's the null hypothesis. Then talking about the alternative hypothesis, alternative hypothesis, that is H1 or HA. Okay, H1 or HA for the alternative hypothesis. So here you just say the sample mean is different. The sample mean is different from the population mean. Different from the population mean. Or to match the second statement, there's no significant difference between the sample mean and the population mean. So you can say there is significant difference. There is significant difference between the sample mean and the population mean. Or you can still say that your HA is such that the X bar is not equal to mu. So either of these three should be fine. Just be consistent in your use for null and alternative hypothesis. Okay, so that's what your hypothesis can be. So of course, just like we saw initially, right? The first thing you want to say is state the hypothesis, which I just explained now. You can choose a significance level. Typically, alpha is 0.05, which means we are willing to accept a 5% chance of rejecting the null hypothesis when it is actually true. 3, compute the Z-score. That's use the formula above to calculate the Z-score. 4, find the critical value. That means for a two-tailed test, at alpha equals 0.05, the critical Z value, the critical Z value in that case is usually plus or minus 1.96. And then you have 5. Compare the Z-score to the critical Z value. So if the Z-score is within the range, minus 1.96 and between minus 1.96 and 1.96, then you do not reject the null hypothesis. But if the z-score falls outside the range, then you reject the null hypothesis. Then finally, you make a decision based on the comparison, decide whether to accept or reject the null hypothesis. I just ran over this because I've explained it in the previous video. So I'll take an example to demonstrate everything I've said for the sake of clarity. So let's go for that. Take an example. So suppose a manufacturer claims that the average lifespan of their bulbs of their light bulbs is 1,000 hours. And then you now have a quality control officer, selects a random sample, of 50 light bulbs, and finds that the average lifespan is 980 hours. It's 980 hours with a population standard deviation of 60 hours. Okay. So the officer wants to test. The officer wants to test if the true average lifespan is different from 1,000 hours. Okay. So how does this go? So this is like the population mean, right? This is like the population mean right here. So this is sample size of 50. This is sample mean, and then this is the sample standard deviation. Oh, yeah, this is a population standard deviation. Then the officer wants to, so then the test is the next thing. So let's see. Let's do step one. Step one, you set up the hypothesis, right? That's the first thing. State the hypothesis. State the hypothesis. That's the first step. State the hypothesis. So, of course, H naught is that the average lifespan is 1,000 hours. Okay. That means mu is equal to 1,000. Then 2, HA now, the average lifespan is not 1,000 hours, meaning that mu is not equal to 1,000. Okay. So that is step one. Then step two, you want to choose a significance level. Choose a significance level. So in that case, you have, usually we like to take 0.05. So you just want to give 5% chance of error. Then we do step three. Step three, you compute the z-score. Compute the z-score. Compute the z-score. And for the z-score, you already know that it's Z equals X bar minus mu all over sigma divided by square root of n. And in this case, right, the sample mean, when the sample was taken, X bar was found to be 980 hours. Okay. Then, of course, we know mu is the population mean, which is 1,000 hours. Then we know sigma. Sigma is the population standard deviation, which is given as 60 hours. And then we have the sample size n, which is 50. 50 is the sample size. So in that case now, to compute z, so we just have X bar minus mu. Okay, I've stated the formula already, so we can just go ahead and apply. Okay, well, it's not too much. Let me just do it again. Sigma all over square root of n. So that means we have 980 minus 1,000 divided by 60 divided by square root of 50. So that the Z score is equal to minus 20 over 60 divided by square root of 50 is 7.071. Okay, so, and that means Z equals minus 20. 60 divided by 7.071 is like 8.485. So that the Z score finally is approximately minus 2.36. Minus 2.36. This is our Z score. So that is step 3 or step 4, right? That's it's step 3 where we compute the Z score. So now that the Z score has been computed, the next thing is we go for step 4. So step 4, find the critical Z value. Find the critical Z value. So, and since we are doing a Z test, right? So we know that for alpha, you can use the table for this. So find alpha equal, so for alpha equals 0.05, which we have chosen, the critical value, the critical values rather are plus or minus 1.96, plus or minus 1.96. So now that takes us to step 5. Step 5. So step 5 is to compare the Z score, to the critical value, Okay. So don't forget, the Z score is minus 2.36, and then the critical value, which is Z alpha, this is the critical value. Yeah, that's like Z alpha, so to speak, is equal to 0.05. Sorry, the critical value now, which corresponds, that's more like Z at 0.05, since our alpha is 0.05. Okay, I think we've stated that already. For alpha is 0.05, the critical values are plus or minus 1.96. So Z at 0.05 is simply what we've stated already. That's plus or minus 1.96. Of course, because this is minus, now we just settle for minus 1.96. So now we can say that this is step 5, right? So we want to compare the two. So we see that the Z score of minus 2.36 is less, minus 2.36 is less than minus 1.96. So it falls within the rejection region, So in that case, we reject the null hypothesis. Okay. So we reject the null hypothesis because minus 2.36 falls within the rejection region of minus 1.96 and 1.96. To drive that home, we go to step 6, where we make a final decision. So we say, make a decision Okay. So we have this. We say since the z-score is outside, okay, it's actually outside the range, not within the range, sorry. Since the z-score is outside the range, of minus 1.96, 1.96. So you can see that minus 2.36 is somewhere below this. Minus 2.36 is somewhere here. So it's not within this range. So since that is the case, we have to reject. So we reject the null hypothesis. Okay. So in conclusion, we say that based on the z-test, there is enough evidence to reject. There is enough evidence to reject the null hypothesis at the 5% significance level. Therefore, we conclude that the true average lifespan of the light bulbs, is different, is significantly different, from 1,000 hours. Okay. Because the null hypothesis, which we already stated to be that the average lifespan is 1,000 hours, that should be rejected. Okay. So this should actually be here. So with that, we've come to the end of this video on z-test. So watch out for other types of tests. So think I have 7 other tests after this. So let's watch out for all that as we move on later on. So if you have not subscribed to this channel, be sure to do that. Also hit the notification bell so you can always get alerted when a new video is released. Don't forget to also comment. Tell me if you like me to teach a particular topic or you want me to solve a problem. Then like and share so that more people can have access to this information. Until I see you next time, have a great time. Bye.